In this video, I will share how to derive an expression for electric field due to two parallel charged sheets. Let us suppose these are two sheets which are parallel to each other. Let me call this sheet as sheet A, and there is another sheet placed near it. Suppose this sheet is sheet B. This sheet has positive charge, and suppose this sheet also has positive charge. But charge density is different on both the sheets. Suppose sigma A represents surface charge density of sheet A and sigma B represents surface charge density of sheet B. Now, what will be electric field due to single sheet? As we know, electric field lines always move away from positive charge. So electric field due to this sheet A can be represented along this line everywhere, and on this side it will be like this. So these lines represent electric field due to sheet A. Similarly, electric field due to sheet B can also be, let me call this as electric field EA due to sheet A. EA vector. Similarly, B sheet also is positively charged. Electric field lines due to this will be along this direction, that is away from positive charge. In this portion, it will be in this direction, and this portion also it will be EB vector, because electric field lines always move away from positive charge. Now this whole space around the two sheets can be supposed to have three portions. Let me call this as portion number 1, this portion middle of the two as portion number 2, and this portion as portion number 3. I will derive expression for electric field total in portion 1 separately, portion 2 separately, portion 3 separately. In this case, total electric field in portion number 1 can be written as minus EA minus EB. Similarly, in this portion, I can write total electric field in portion number 3 as EA plus EB. I have considered the electric field lines towards the right hand side as positive and electric field lines towards left hand side in left direction as negative. And electric field in this middle portion can be written as, now EA is towards the right, it will be taken as positive, and EB is towards the left, it will be taken as negative. So this is the magnitude of resultant electric field in the middle portion on left hand side of plate A and on right hand side of plate B. Now we have to put the values of these electric fields and simplify. Now electric field due to single sheet is given as surface charge density divided by 2 times epsilon naught, permittivity of free space. Now I have to write expression for electric field due to sheet A, so I will write here sigma A. Similarly, minus sigma B divided by 2 epsilon naught. After simplification, I can write electric field in the first case in this portion as minus 1 upon 2 epsilon naught multiplied by sigma A plus sigma B. This is how we can derive the expression for electric field on left hand side of sheet A. Similarly, by putting values of EA and EB, we can prove that electric field in the second portion is equal to 1 upon 2 epsilon naught multiplied with sigma A minus sigma B. This is the second portion. In the third portion, we shall get answer E equal to 1 upon 2 epsilon naught bracket sigma A plus sigma B. This is how we can derive expression for net electric field in three portions around the charged parallel sheets. Now let us discuss a special case. Special case means, let me suppose the two sheets A and B are equally and oppositely charged. Means suppose sheet A is positively charged and sheet B is negatively charged, and charge density of both the sheets is same. Let us suppose this sheet has charge density plus sigma, this sheet has minus sigma. Means magnitude of charge density on both these sheets is same. Then what will happen to the previously derived expressions for electric field in the first portion, in the second portion, and also in the third portion? Let's modify the previous relation by putting the values of sigma A and sigma B equal to plus sigma and minus sigma. Sheets are equally and oppositely charged. From previous equations, we can prove that electric field in the first portion comes out to be 1 minus 1 upon 2 epsilon naught. Inside the bracket, there will be plus sigma, minus sigma, and result will be equal to 0. Similarly, if I put the values in for electric field in the second portion, I will get 1 upon 2 epsilon naught plus sigma, answer comes out to be sigma divided by epsilon naught. And electric field in the third portion, that is on right hand side of sheet B, we shall get 2 epsilon naught plus sigma minus sigma equal to 0. From these three relations, it is clear that no electric field will exist on left side of plate A and on right side of plate B. Electric field is non-zero only in the portion in between the two sheets. So we can conclude that net electric field due to two parallel equally and oppositely charged sheets is non-zero only in the space between the sheets, and the answer for net electric field is equal to sigma upon epsilon naught. That's all.